the bottom line is that they can train a model, and you can see they basically use a deep learning algorithm to study these graphs, and they ask the model to predict a certain property. So here they took 107 million compounds that had some antibiotic data. And instead, so what the funnel showed is that the standard approach is to go to the 10 to the power of 8 and do a chemical screen, which is a robotic screen, which is very laborious. They actually reduced it to 10 to the power of 4, okay? And they have a model where they predict a property, they test it, and they feed it back to the model. And then they showed that they can learn a property without understanding anything about chemistry. They learned what a compound that has an antibiotic activity looks like. And they predicted 23 different compounds. They took 8 that no chemist would say has an antibiotic activity, because those structures, chemists have some intuition on what to design, but they took some 8 structures that were completely out of the blue. And they showed that at least one of them, I think more of them, I don't remember the exact number, but they showed experimentally that they were able to predict antibacterial activity. That paper created a big hype in the field. It basically meant that now we can move towards designing computationally compounds instead of screening them chemically. And we're basically approaching the point where we can ask a computer, what is this molecule going to do? Without even testing it, because it's going to learn many, many different properties. I actually visited Ben-Gurion University last week, and I saw some of the work based on this paper where they predict all sorts of properties for structures. So this is becoming now very exciting because it allows us to create very specific compounds very fast.